I decided to connect it to my discrete mathematics course because we're currently going through finite state machines, and I thought that this would be a fun way to connect them. I did set up some finite state machines before because entering them is a little slow, so I have some just to show how they work. All right, so now we have the program running. So like I said, I can display the final state machines I have. So I currently have two stored in a text file that gets pulled from. So let's show creating a final state machine. So we can call this one test. It's been created. So then we can go to add states. We type in test to say we want to modify that one. We enter state. Let's call it state 0. And then start state. This would be the start state. Accept state. It would not be the accept state. And then you can add another state for test. Ready? And then we can do a state 1. And then we can say, no, this is not the start state. Yes, this is the accept state. And then you connect them by adding a transition. So we can go into test, re-enter from state. So that is the one that you essentially start at. So in this case, it would be we're going from 0. Let's say if we get an A, then it's going to loop back to itself. So if we add another transition, we can go to test. Then we start at 0, and then we get a B. Then we go to state 1. That is how you can create a finite state machine using this program. Then you can do it to display, and then you can see it is displayed here. So you can see that 0 is the start state, 1 is the accept state, and then which inputs lead to which state. So then if we actually want to simulate one, we can go to 5. Let's start with the question 4 finite state machine. And then let's just go with 1, 0, 0, 0, 1, 1 to start with. So as we can see, you have an alternating 1, 0 right here. So this one should pass. Yes, so it is accepted, and it tells you that it ended at the accept state of C. So if we do another simulation of question 4, we can then input one that we know will fail, which will be either all 0s or all 1s. Then we hit that, and then yes, it says rejected, ended at non-accept state D, which if we look back at here, we start at A, we get a 0, we go to D. And then we're at D, we get another 0, we move back to D, move back to D, move back to D, which makes sense. Then we can simulate the AB1. In first test one that we know will work, which is just AB. Let's throw on an extra AB there. And that one will end at the acceptance state because it has the AB in the string. And we do that. And yes, it does accept it, ended at accept state 4, which is what we were looking for. We do that again with AB, but then we do a string that we know will fail. So let's do A, B, B, A, B, A. So that one shouldn't pass because it doesn't have A, B. And yes, it doesn't. So it's rejected, and it tells you that it is ended at the non-accept state 1. The big thing that I added on this one to sort of improve it from the ones that we've been doing, like from weeks 1 to 5. You saw there was a save and quit option. What am I saving? Well, it's the final state machine text. So I had it so that when you enter a final state machine, it is then stored. So you have question 4 final state machine right here. And then you have the test that we made, and it has 2 for 0 and 1. And that one was pretty interesting because I needed to actually dig into how to send to a text file, but also pull from the text file in C++, which is something we hadn't touched on. Yes, I think that is the brunt of it. But yeah, it was fun. I hope this works for the project.